Hello, fellow chemists. In this video, we're going to take a look at atomic structure. This is labeled as a basic video because there's no background information that you need to understand to follow along with what I'm going to be talking about. So let's get started. Whenever anybody talks about atomic structure, really what they're talking about is how the fundamental particles, the protons, neutrons, and electrons, how they exist within an atom. So let's start off by drawing an example of an atom. The first thing I'll draw is what would represent the nucleus or the center of the atom. And we'll make that as this yellow center here. Now, within the nucleus, that is where all of the protons and the neutrons exist. So I'll put a P here for protons and a plus because all of the protons have a positive charge. And then I'll put an N down here as well, and that'll be for neutrons. And I'll put a 0 next to the neutrons because they're neutral or they do not have a charge. And these protons and neutrons, they exist in the center of the atom, which is called the nucleus. Now, outside of the nucleus is what's called the electron cloud, and that is a much larger area of the atom. And then I'll represent that by several circles here because there's different levels of the electron cloud that electrons can live in. And in these electron clouds, this is where all of the electrons for an atom exist. And the electrons have a negative charge, so I'll put a little negative next to them. So these green circles represent the electron cloud. Now, in the nucleus, even though it's very small, that contains 99% of the mass for an atom, but it only contains 1% of the space or volume. And the electron cloud, that is over 99% of the volume or space, but only, or actually less than, 1% of the mass of the atom. So let's talk about this in a little bit more detail here. This atom is not drawn to scale. And what I mean by that is the electron cloud is much, much larger than the nucleus. I have the nucleus drawn bigger here just so we can kind of see what's in it. But to kind of give you an idea of the scope and the comparison of the electron cloud to the nucleus, if you were to blow an atom up into such a large size that you can actually see it with your own eyes, let's say you blew an atom up to the size of a football field. The nucleus would be the size of a golf ball sitting at the center of the football field, and the entire rest of the football field would be the electron cloud. So the electron cloud is thousands of times larger than the nucleus. But you may say, well, wait, if the electron cloud is so large, why does it contain such a tiny percentage of the mass of the atom? And what that means is most of the atom is empty space. Almost all of the mass of the atom is in this tiny, dense center, the nucleus, where the protons and neutrons exist. Well, to explain why almost all of the mass of the atom is in the nucleus and almost none of the mass is in the electron cloud, we have to take a look at, well, how much do these protons and neutrons and electrons weigh? And if we take a look at a proton weighs about 1.672 times 10 to the negative 27 kilograms. Now, when you think about how much that weighs, that's an extremely light weight times 10 to the negative 27th. That's like a billionth of the weight of a piece of hair. So it's super light. So rather than chemists say, well, a proton weighs 1.67 times 10 to the negative 27th kilograms, they just say that that's about 1 atomic mass unit. So it's a lot easier to say than this large number out here. So a proton weighs 1 AMU, or 1 atomic mass unit. Now a neutron is actually slightly heavier than a proton. A neutron weighs about 1.674 times 10 to the negative 27 kilograms. but they're pretty close in mass. So they say a neutron also weighs about 1 atomic mass unit. So if you had a proton, it would weigh 1 atomic mass unit. If you had a neutron, it would weigh 1 atomic mass unit. If you had a proton and a neutron together, you would say that that weighs 2 atomic mass units. You say, all right, well, how much do the electrons weigh? Remember, the electron cloud's extremely light, so an electron weighs about 1/2000th the weight of a proton or a neutron. An electron weighs 9.109 times 10 to the negative 31 kilograms. So that's even lighter. So again, an electron is about 1/2000th the weight of a proton and a neutron. So scientists say, well, that effectively weighs nothing. So when they're trying to figure out how much the mass of an atom weighs, all they do is they add up the protons and the neutrons, and they don't worry about the electrons. That would be equivalent to if an elephant was a proton and a feather was an electron, and you were trying to find out how much that elephant weighed, and the elephant got on a scale, and then that feather floated on the scale, and you would say, wait, 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 don't weigh that elephant because that feather is going to throw the weight of it off. No, the feather's so light, it's not going to affect the weight of that elephant. Just like these electrons are so light, they don't affect the weight of this atom at all. So to find out how much atoms weigh, all you do is you add together the weight of the protons and the neutrons. So for example, if we had an atom that had 6 protons in it, 6 neutrons in it, and 6 electrons in it, and we wanted to know, well, how much does that atom weigh? It would weigh 12 atomic mass units, because you would add the protons together and add the neutrons together, and you don't even worry about the electrons because they're so light. So in review, if we take a look at protons, protons have a positive charge, and they also have mass associated with them. Neutrons have a neutral charge or no charge, and they too also have mass associated with them. And an electron has a negative charge, but is considered massless, or so light it's negligible. So let's answer a couple of questions based on what we learned about the atomic structure. So the first one says, which subatomic particles are contained in the nucleus? Well, if we look here, you have all of the protons and all of the neutrons exist in the nucleus, and all of the electrons are out in the electron cloud. So for this one, it would be the protons and the neutrons exist in the nucleus. The second question asks, which subatomic particle has a negative charge and negligible mass? Look down here, the electron has a negative charge and basically no mass or negligible mass compared to the proton and the neutron. And the last question says, which subatomic particle has mass but no charge? If we look at the neutron here, it does not have a charge, but it does have mass associated with it, and that's at 1 atomic mass unit. So the answer to this one would be the neutron. Well, that is it for this lesson. I hope you learned something, and I will see you in the next video.